Imagine if you could see the tiniest, fastest thing in the universe, faster than anything you've ever seen before. Not just fast, but so fast that it's harder to catch than lightning in a bottle. I'm talking about the movement of electrons, the little particles that make up atoms, moving at the speed of light. Well, guess what? Thanks to three incredible scientists, we can now see and measure those movements with unbelievable precision. And they just won the 2023 Nobel Prize in Physics for it. Stick around as we uncover how they did it and how this breakthrough will change our world. How three scientists won the Nobel Prize for Attosecond science. Okay, let's start with something that might sound a little wild. Attoseconds. Now you might be thinking, what the heck is an attosecond? Well, an attosecond is 1/1000th of a billionth of a second, so 1/quintillionth of a second. To put it in perspective, if 1 second was the age of the entire universe, an attosecond would be the blink of an eye. Think about that. It's so fast that it's like trying to catch a shooting star with your bare hands. Now, here's the catch. Electrons move faster than that. They travel at speeds so fast that no camera in the world can catch them. Until now. Three brilliant minds figured out how to not just catch these electrons in action, but freeze their motion like stopping time. Their names are Anne Lhuillier, Pierre Agostini, and Ferenc Krauss. These three scientists took a giant leap forward in physics, and that's why they won the Nobel Prize. Let's break down what these scientists did and why their discoveries matter, because trust me, what they've done is about to change everything. Imagine you're watching a car race, but the cars are moving at the speed of light. How would you capture that? Impossible, right? Unless you had a camera that could take pictures in attoseconds. And that's exactly what Anne Lhuillier did. She discovered something amazing back in 1987. By firing laser light at a gas, she found that the electrons in the gas atoms could be kicked out, like a ping-pong ball bouncing out of a table. But here's the kicker. When the electrons were kicked out, they sent out light pulses that were even shorter than the blink of an eye, attosecond pulses. And this wasn't just a flash, it was multiple flashes of light that we could use to understand the speed and motion of electrons. Fast forward to 2001. Pierre Agostini stepped in and took this discovery to the next level. He used these pulses to measure the timing of electron movement. Think of it like trying to capture a race car's speed with a super advanced stopwatch that's accurate to the trillionth of a second. His work helped us streak electrons, allowing us to measure their movement at the attosecond level. Now enter Ferenc Krauss, who in 2001 pulled off a feat that was thought impossible. He figured out how to capture a single attosecond pulse. Imagine being able to freeze a split second of time and study it in incredible detail. That's what Krauss did. By isolating a single flash of light that lasts only an attosecond, he could now study electron movement without any distractions. It's like taking a picture of a speeding bullet in midair and being able to see the details of every molecule. That's how precise these pulses are. So, why does this matter? Why should you care about something so tiny and fast? Well, it's simple. Electrons are everywhere. In the atoms that make up everything around us, our phones, our computers, the energy that powers our lives. If we can study how electrons behave on such short timescales, we can unlock some of the most mysterious forces of nature. It's like this. If you've ever watched a movie and wanted to understand how the special effects were done, you know you need to understand the details of how everything moves. Electrons are the special effects of the real world. Understanding how they work could lead to breakthroughs in quantum computers, medicine, and even energy technologies like solar cells. Here's where it gets even more exciting. Imagine using these attosecond pulses to improve electronics. If we can measure and control electron behavior, we could build faster computers, smarter phones, and super efficient batteries. Quantum computers, the next frontier in computing, could become a reality much sooner because we now have the tools to manipulate quantum states more efficiently. In medicine, we could see inside cells at a level never before possible, which means earlier detection of diseases like cancer before they spread. And in chemical reactions, we could design better drugs, discover new materials, and even improve energy efficiency across the board. So to wrap it all up, these three brilliant scientists, Anne Lhuillier, Pierre Agostini, and Ferenc Krauss, did what many thought was impossible. They caught the fastest thing in the universe, electron movement, and have now given us the tools to study it in real time, making their discoveries one of the most important breakthroughs in modern physics. Attosecond physics might sound like science fiction, but it's very much science fact. These innovations will affect everything, from how we use electronics to how we treat diseases, and we have these Nobel laureates to thank for it. If you're as fascinated by the idea of studying the fastest things in the universe as we are, make sure to hit that like button, subscribe, and ring the bell for more mind-blowing science content. And hey, tell us what you think in the comments. How do you think Attosecond science will change the world in the future? We can't wait to hear your thoughts. Thanks for watching. See you in the next video.